Did you know there's a supervolcano hiding under your feet? It's here. It's here under Yellowstone National Park, and it's one of the largest active volcanoes on Earth. But the craziest part about this magma chamber is that we only discovered it by accident. Hi, it's me, and this is my channel. In late August of 1985, two scientists were flying over Yellowstone National Park when they noticed some unusual heat signatures coming from the ground. Now, these two weren't just sightseeing. They were looking for geothermal features like geysers and hot springs because their research focused on the mechanics of heat transfer. So, when they saw something interesting, they landed their plane and set up some equipment to measure the temperature of the ground in that area. Now, this was good old-fashioned shoe-leather science. These two scientists walked around taking measurements, collecting steam samples, and identifying potential drilling sites for future research projects. Then one of them, a guy named Jacob, noticed something strange. He felt the ground begin to tremble slightly beneath his feet. At first he wasn't sure if it was an earthquake or something else, but soon enough he felt it again. It happened about every 20 minutes and lasted for 10 seconds at a time. Feeling a small earthquake every half hour isn't normal by any stretch of the imagination, but even though this was unexpected, it gave the team an incredible opportunity to do some totally unplanned research. In addition to measuring the ground temperature, they began recording the strength and timing of these mysterious rumblings. Then they drilled a hole through the thick layer of clay and rock to access the steam underneath. The steam had a temperature of 410 degrees Fahrenheit or 210 degrees Celsius. That's hotter than a typical kitchen oven, and it suggested that something really big was happening beneath the surface. But what was causing the earthquakes? Well, one of the most reliable ways of finding out is to listen to what's going on underground. When you think about sounds in the ground, you probably imagine things like footsteps, car alarms, and singing sand. But the earth produces a lot of other noises too. As water seeps into cracks and pores in the rocks, it creates pressure. When the pressure increases fast enough, it makes a cracking sound. Scientists call this rock fracturing. It's similar to how water dripping onto concrete can create smaller and smaller cracks over time until one day the whole thing breaks apart. This is exactly what happened in 2018 when the largest man-made dam in the world collapsed. And the same thing happens with the Earth. The cracks created by the pressure of water help create seismic waves that travel through the planet and can be picked up by sensitive microphones called seismometers. The cool thing about these waves is that they have unique properties. Each type of wave moves in a different way, and they all travel at different speeds. So when scientists analyze seismic data, they can use it to understand what's happening deep within the Earth, like where the waves originated, how much energy they had, and what kind of material they moved through. So back in 1985, the team set up a seismometer to try to figure out what was causing those earthquakes. They analyzed the waves and discovered something weird. The waves weren't coming from any of the usual places. They were coming from below the magma chamber that powers Yellowstone's famous geysers. Yellowstone is home to hundreds of the world's most impressive geothermal features, including the largest concentration of geysers anywhere on Earth. These features are powered by magma, which is molten rock found deep within the Earth. Now, typically, magma chambers look something like this. There's a blob of magma down here, and then there's a bunch of gases and hot water trapped inside the pores of the rocks above it. You see, when magma comes into contact with water, it heats it up and turns it into steam. The steam creates pressure in the surrounding rocks, and that pressure forces hot water up toward the surface. Eventually, the water reaches a point where it can't move anymore, so it starts to cool and solidify. Then new water seeps in, and the process starts all over again. This recycling of water is what creates the amazing array of geothermal features across Yellowstone. But the magma chamber that the team discovered in 1985 didn't look like this. It looked like this. There was a huge pile of solid rock between the magma and the geothermal features. Even weirder, They realized that the earthquakes were actually steam explosions caused by the pressure of water vapor building up beneath that layer of solid rock. The way they figured this out was by using a technique called tomography. Tomography allows scientists to create images of objects that are hidden inside the Earth. To do this, they send seismic waves through the ground by placing a seismometer at one end and creating a controlled source of vibrations at the other. Think of it like dropping a rock into a well. Once the initial seismic waves reach the boundary between one material and another, some of them get reflected and others get refracted or bent. By measuring how the waves change speed and direction, scientists can construct an image of what's inside the Earth. Using this technique, the team built a model of the magma chamber. They discovered that instead of being connected to the geothermal features above it, the magma chamber was sealed off by a solid layer of rock that was several miles wide. Beneath the magma chamber, there was a massive pocket of superheated water vapor. The vapor was created when the magma heated up the rock and released its fluids, and the rock acted like a cap that kept the vapor from escaping. The vapor continued to build up pressure until it forced the rocks around it to fracture and explode like a shaken bottle of soda. The researchers were able to calculate that the magma chamber had been filling up with water vapor for thousands of years. At some point, the pressure became so great that it overcame the strength of the rocks and triggered a massive explosion. The steam blew through the fractured rocks and created the large network of cavities and vents that we see today. The scientists didn't stop there. They used tomography to take an even deeper dive into the inner workings of the magma chamber. They discovered a second layer of hot rock beneath the vent system. This outer layer was full of fractures that allowed hot water to escape, while the inner layer was mostly solid. It seemed like the hot water vapor was pushing against this inner layer, heating it up and creating conditions ripe for the formation of gemstones. You see, when water vapor comes into contact with certain metals, it can create exotic minerals. Take diamonds, for example. Diamonds are formed from carbon atoms that experience intense heat and pressure deep within the Earth. The same thing happens with gemstones like tourmaline and topaz. The hot water vapor in the magma chamber provided the perfect environment for these gems to grow. What's more, the rocks that surround the magma chamber contain traces of lithium, beryllium, and fluorine, elements that are essential for the formation of these minerals. All of this suggests that the magma chamber may also be a source of gemstones. Since the discovery in 1985, scientists have revisited the site several times to see if anything has changed. They have continued to monitor the seismic activity, but there haven't been any major changes yet. However, this doesn't mean that the magma chamber is dormant. It could erupt again at any moment, although experts say it's not likely to happen anytime soon. For now, we'll just have to wait and see what happens next. And we won't have to wait long. Thanks to the work of these scientists, we are now able to monitor the magma chamber closely and make predictions about its behavior. Who knows what secrets it might reveal next? If you enjoyed this video, you might want to check out my video on Yellowstone's supervolcano. You'll learn all about the history of the park, including the super eruption of 640,000 years ago. Thanks for watching. See you next time.